Hello friends, welcome back to my channel. Today I would like to share with you the concept preparation of salts. A salt is a compound that's formed when the hydrogen atom in an acid is replaced by a metal. For example, if we replace the hydrogen in HCl with a potassium atom, then the salt potassium chloride is formed, KCl. The uses of salts include fertilizers, batteries, cleaning products, healthcare products, and fungicides. Naming salts. The name of salt has two parts. The first part comes from the metal oxide or metal carbonate used in the reaction. Second part comes from the acid. For example, hydrochloric acid always produces salts that end in chloride and contain the chloride ion Cl-. Other examples: sodium hydroxide reacts with hydrochloric acid to produce sodium chloride. Zinc oxide reacts with sulfuric acid to produce zinc sulfate. General solubility rules for salts. Sodium, potassium, and ammonium salts are soluble. Nitrates are soluble. Chlorides are soluble except lead and silver. Sulfates are soluble except barium, calcium, and lead. Carbonates are insoluble except sodium, potassium, and ammonium. Hydroxides are insoluble except sodium, potassium, ammonium, and calcium. Partially. Preparation, separation, and purification of soluble salts. These are done by the reaction of an acid with an alkali by titration, excess metal, excess insoluble base, excess insoluble carbonate. Reaction of an acid with an alkali by titration method. This is an outline method for carrying out a titration in which an acid is added to alkali. Use a pipette and pipette filler to add 25 cubic centimeter of alkali to a clean conical flask. Add a few drops of indicator and put the conical flask on a white tile. Fill the burette with acid and note the starting volume. Slowly add the acid from the burette to the alkali in the conical flask, swirling to mix. Stop adding the acid when the endpoint is reached. The appropriate color change in the indicator happens. Note the final volume reading. Repeat steps 1 to 5 until you get concordant readings. The same method works for adding an alkali to an acid. Just swap around the liquids that go into the conical flask and burette. Heat the resulting solution in an evaporating basin to partially evaporate, leaving a saturated solution, crystals just forming on the sides of the basin or on a glass rod dipped in and then removed. Leave to crystallize, decant excess solution and allow crystals to dry. Reaction of an acid with excess metal. Acid plus metal gives salt plus hydrogen. The metals usually used in the method of salt preparation are the acid metals, that's magnesium, aluminum, zinc, iron, and tin. Example: preparation of magnesium chloride from magnesium and hydrochloric acid. Reaction of acid with excess metal. The method: heat acid until warm, then add excess metal, stirring constantly until it stops disappearing. By using an excess metal, we are making sure that all of the acid has reacted and some magnesium is left at the end of the reaction. Filter the mixture to remove the excess metal. The salt solution is evaporated slowly to form a saturated solution of the salt. The hot concentrated salt solution produced is tested by dipping a glass rod into it. If salt crystals form at the end of the rod, solution is ready to crystallize and it's left to cool. Any crystals produced on cooling are filtered and dried between clean tissues. Reaction of an acid with insoluble carbonate. Acid plus carbonate gives salt, water, and carbon dioxide. Example: preparation of copper to nitrate from copper to carbonate and nitric acid. Heat acid until warm, then add excess metal carbonate, stirring constantly until it stops disappearing. Filter the mixture to remove the excess carbonate. The salt solution is evaporated slowly to form a saturated solution of the salt. The hot concentrated salt solution produced is tested by dipping a glass rod into it. If salt crystals form at the end of the rod, the solution is ready to crystallize and is left to cool. Any crystals produced on cooling are filtered and dried between clean tissues. Reaction of an acid with insoluble base. Acid plus base gives salt plus hydrogen. This method can be used to prepare a salt of an unreactive metal such as lead or copper. Example, preparation of copper to sulfate from copper to oxide. The method of preparation is same as that of the acid and carbonate. To make an insoluble salt, we follow the method precipitation. Two soluble salts need to react together in a precipitation reaction. Example, silver chloride is an insoluble salt. It can be made by reacting a soluble silver salt with a soluble chloride salt. Silver nitrate and sodium chloride are both soluble. When their solutions are mixed together, soluble sodium nitrate and insoluble silver chloride are made. Silver nitrate plus sodium chloride gives sodium nitrate plus silver chloride. AgNO3 plus NaCl gives NaNO3 plus AgCl. The ionic equation for this process is as follows. Ag plus Cl minus gives AgCl. The silver chloride appears as tiny particles suspended in the reaction mixture. This is a precipitate. The precipitate can be filtered, washed with water on the filter paper, and then dried in an oven. Hydrated and anhydrous salts. Water molecules included in the structure of some salts during the crystallization process are known as water of crystallization. Salts that contain water within their structure are called hydrated salts. Example, hydrated copper 2 sulfate is CuSO4.5H2O. Hydrated cobalt 2 chloride is CoCl2.6H2O. The formula shows the number of moles of water contained within 1 mole of the hydrated salt. A compound which does not contain water of crystallization is called an anhydrous compound. Example, anhydrous copper 2 sulfate is CuSO4. Anhydrous cobalt 2 chloride is CoCl2. Blue copper sulfate is heated, which means that the copper and sulfate ions in its crystal structure are surrounded by water particles. When heated, the water is driven off, producing anhydrous copper sulfate, which is a white solid. The reaction is reversible, which means that as soon as any water is around, anhydrous copper sulfate will be converted back into the blue hydrated form. The forward reaction takes in heat energy that's endothermic, which means that the reverse reaction is exothermic. Thank you so much for watching this video.